In this lesson, we'll be talking about the difference of squares. The reason that it's called a difference of squares is that there has to be a subtraction sign in the middle of both terms, and both terms have to be perfect squares. So you can see right here, let's see, right here, if you have a squared minus b squared, that's going to equal a plus b times a minus b. So if you want to pause it and read the rest, you can. I'm going to go ahead and work out this problem. So it says factor 4y squared minus 9. So we see that we have a difference because it's subtraction, and both 4y squared and 9 are perfect squares. So I'm going to factor. If there was a greatest common factor, I would factor that out first, just like any factoring problem, but in this case, there's not. So you ask yourself, what times what gives you 4y squared? Well, 2y and 2y. And what times what gives you 9? 3 and 3. And one of these has to be a positive and one has to be a negative. That is your answer. Now I'll show you why this works, okay? If I distribute it to check, I would get 4y squared minus 6y plus 6y minus 9. And what's going to happen with both of these middle terms is they cancel out. And so you would just get that, which is what we started with. Okay, in this problem, I have 16b to the fourth minus 36b squared. Is there a greatest common factor that I can factor out of these? Yes, they both have a 4b squared that I can take out. When I did, if I factored out a 4b squared, what times 4b squared gives me 16b to the fourth? Well, 4b squared. What times 4b squared gives me negative 36b squared? Well, negative 9. So am I done? No, because 4b squared, I'll just rewrite that, bring that down. This parentheses is also a difference of squares, okay? So what times what gives me 4b squared? 2b and 2b. What times what gives me 9? 3 and 3. One has to be a plus, one has to be a minus, and there you go. That's my final answer. Okay, this problem is a quadrinomial, so it's 4 terms. Anytime you have a quadrinomial, you're going to split it up into grouping. Okay, so you're going to basically split it in half. Now, you say, what can you bring out of this first set of parentheses? Well, both of them have a 3x squared. So what would be left? You would have an x and a plus 1. Now, what can I pull out of the second set of parentheses? You have a negative 12 that you can pull out. If I did that, I'd be left with x plus 1 because negative 12 times x is negative 12x and negative 12 times 1 is negative 12. Now you're going to bring what's in parentheses together and what's outside of the parentheses together. Okay? Now I'm going to switch that around because I want to and I need to because I need to pull out something else of that are parentheses. So what can I pull out of this parentheses? What's the greatest common factor? A 3. When I do, I'd be left with x squared minus 4. So then what's going on with this parentheses now? It is a difference of squares. So I'm just going to write this one x plus 1, but I do need to split that first parentheses up. So what times what is x squared? X times x. What times what is 4? 2 and 2. One has to be addition, one has to be subtraction, and you have your final answer. Solve 27x cubed equals 147x. We know from other factoring problems that the first thing that you want to do is set one side equal to 0. So I am going to subtract 147x from both sides. The reason I'm moving that is because I want the term with the highest exponent to be positive. It's just better. So I get 27x cubed minus 147x equals 0. Now I have to pull out the greatest common factor. So if I pull out the greatest common factor from these, I would pull out a 3x. When I do, I would be left with 9x squared minus 49. Okay, now you can see that 9x squared minus 49 is a difference of squares. So what times what is 9x squared? 3x and 3x. What times what is 49? 7 times 7. One has to be addition, one has to be subtraction. Now, if all I was doing was factoring, this would be it, but I'm not, I'm solving. So I set up each of these equal to 0 and solve individually. So if I did that, if I divide by 3, I would get x equals 0 right here. Subtract 7, divide the 3. We get x equals negative 7 over 3. And add the 7. Divide the 3. And I get x equals 7 over 3. So all of these are my answers. In this last problem, I'm factoring 7xy squared minus 28x cubed. So obviously I need to factor out the greatest common factor. So 7 can go into both of those. I have at least one x, and I don't have anything else in common. That's all I've got. So what would I multiply to 7x to get 7xy squared? A y squared. What would I multiply to 7x to get negative 28x cubed? Well, 7 times negative 4 gives me negative 28, and I need 2 more x's. So now I have a difference of squares. Okay, so I'm going to write 7x, and then I'm going to write my parentheses. What times what gives me y squared? Y times y. What times what gives me 4x squared? 2x and 2x. One needs to be an addition, one needs to be a subtraction, and I am done.